Hi there again, third grade friends. I'm so excited to be back with you. It's Mrs. Hoffman again, and we're going to do some really great math. I've got some super big vocabulary words for you today, so I hope you have your thinking brains on. Before we get started, there's a couple of things I need you to have in front of you for our lesson today. The first one is your guided practice page. Make sure that you're looking at the one that says day 2 up here, and then you're just going to need a pencil. Make sure, like always, you've got that eraser because sometimes we make mistakes, but that's okay. That's how we learn. All right, while you're gathering those things, let's get ready for our refueling break. Today we're going to do lazy 8 refueling. This is one of my favorite ones. This one you can do sitting up nice and tall or lying flat on your back. So here's our little guy. He's laying back. He looks like he's sleeping. Don't go to sleep on me. All right, here we go. Here's how this works. We're just going to go around his head. We're going to take a deep breath in. And then we're going to go around his feet and let it out. And we're going to do that 4 times. Are you ready? Sit up nice and tall or stretch out nice and flat. Here we go. Big deep breath in. And let it out. Good job. Let's do it again. And let him out. Good job. We're going to do that 2 more times. Here we go. Big deep breath in. Let it out. Last time. Here we go. Make it your best. Big deep breath. And let him out. Great job. All right, now that our brains are ready to go and we're ready to do all this great math work, let me tell you our goal for today. It's a big one. Today we're going to use the commutative and associative properties to explain addition. Now, why would we ever need to explain how we do math or why we do math? That's today's question, so we need to really focus in on that. We're going to use place value to break apart our numbers. So what we did last time is going to come in really handy with what we're going to do today. And then, this is our big one, we need to be able to explain our thinking. Okay? All right, so we're going to watch a quick video here. And as we're watching this video, I want you to really focus on those 2 big words, commutative and associative. Say that with me, commutative. Be careful, don't put that in there. A lot of people try to say commutative. Don't do that. Say it with me, commutative. Great job. And now say associative. Great, fantastic. Now that you've got those words in your head, let's watch this quick video.
The school cooks made 53 turkey sandwiches and 41 ham sandwiches for today's lunch. How many sandwiches did they make? In this lesson, you will learn how to explain addition by using the commutative and associative properties. Why do we have to explain in math? Sometimes you need to prove to other students and teachers you're correct. Other times we compare our strategies with other students to learn a different way to think about the problem. Finally, we might help someone understand the problem by explaining it to them. During this lesson, we're going to use the properties of addition to prove our answers are correct. Remember that place value can help us to explain an addition problem like 43 plus 25. If we break each number into tens and ones, 43 is 4 tens and 3 ones, and 25 is 2 tens and 5 ones. We always put tens with tens and ones with ones, so we could act out the problem by moving the tens and ones together. We end up with 6 tens and 8 ones, or 68. The monkey solved the sandwiches problem. He knew it was an addition situation because he's putting 2 different kinds of sandwiches together. The monkey broke apart each number into tens and ones, and then he added them all together and got an answer of 94 sandwiches. How could he use the properties of addition to explain his answer? Well, what are the properties of addition that could help him? The commutative property of addition tells us that we can add numbers in any order and we will get the same answer. For example, 1 star plus 2 stars is the same as 2 stars plus 1 star. If we replace the pictures with numbers, we see 1 plus 2 is the same as 2 plus 1, because we have 3 on one side and 3 on the other. We can add numbers in any order and we'll get the same answer. The associative property of addition says that we can group numbers together when we add them. No matter which way we make a group, the final answer will be the same. Let's say we're adding 1 plus 3 plus 5. We'll make a picture of this problem using pennies. 1 penny plus 3 pennies plus 5 pennies. We could group 1 plus 3, which is 4, add 5 more, and get 9 pennies. Or we could group 3 plus 5, which is 8, add 1 more, and we still have 9 pennies. No matter which way we group the numbers we're adding, we get the same sum. The monkey added 4 numbers together to solve the sandwich problem. We know from the commutative property that we can add numbers in any order. So let's put the tens together and the ones together. We know from the associative property that we can group the add-ins. If we group 50 plus 40, we get 90. If we group 3 plus 1, we get 4. Add those together, and the answer is 94. They made 94 sandwiches. Here's a different problem. The school cooks peeled 17 cucumbers and 36 carrots for today's lunch. How many vegetables did they peel? Again, this is an addition situation because we're putting together different kinds of vegetables. The monkey can break each number into tens and ones, and then he can prove his answer using the commutative and associative properties. The commutative property says we can add numbers in any order, so he puts the tens and the ones together. The associative property says that we can group our add-ins. 10 plus 30 is 40, 7 plus 6 is 13, so the answer is 53 vegetables. The cooks peeled 53 vegetables for lunch. In this lesson, you learned how to explain addition by using the commutative and associative properties.
Okay, that was a lot of math, wasn't it? And a lot of big words. But let's go back to that original question that I asked you. Why do we have to explain math? Well, there's 3 really good reasons. The first one might be to prove that our answer is correct. How many times do you get an answer that's different than your friends and you have to prove that you're right? So being able to explain your thinking can help you prove your answer's correct. The second reason might be so that you can share your strategy with someone else. The really cool thing about math is that so many times problems can be done in more than just one way. And so if I use a different strategy than you do, we can both share what we've done differently to get the same answer. And then that third really great reason for why we need to explain our thinking is because sometimes we need to help our friends. How many times have you been in class and a friend has asked you to help share your work so that they can understand what you're doing? So those are all reasons why we have to explain our math. There were 2 really big math words in there, commutative property and associative property. So let's talk about those 2 words really quickly. Remember that commutative property said that I could take numbers and I can add them in any order. So think about this, think about this number sentence right here. What is 3 plus 4? Right, it's 7. Okay, well what if I took those same 2 numbers and I flipped them around? And instead of saying 3 plus 4, what if I said 4 plus 3? Now what's the answer? Right, it's still 7. Just because I changed the order of my numbers doesn't mean that I changed the answer. So the commutative property says you can take your add-ins and flip them any way you want and you still get the same answer. But the associative property was a little bit different. That time I need 3 numbers. So what if I had 2 plus 3 plus 4? The associative property says I can group those numbers any way and still get the answer. So I can start by grouping these 2 numbers. What's 2 plus 3? Yep, 5. And if I do 5 plus 4, what answer do I get? Perfect, I get 9. Well, what if I take that same problem and this time I group my numbers differently? So I'm going to use that associative property again, but I'm going to do a different group. This time I want to group 3 and 4. Well, what's 3 plus 4? Perfect, 7. And 7 plus 2, isn't that still 9? Perfect, good. So the commutative property says you can switch the order all you want and it won't change your sum. And the associative property says you can group them in any way you want and it won't change the sum. Remember, the sum is the answer to an addition problem. All right, so grab that student practice guide and your pencil and let's try this together. I think you're going to notice that what we did last time is going to help us a lot this time. Okay. We're going to do 34 plus 65. So we're going to start with some smaller numbers here. The first thing I want to do is I want to break these numbers apart into tens and ones. Now last time we broke them apart and we drew base 10 blocks. But this time we're just going to break them apart by their place value. So in the number 34, what does the number 3 actually represent? Are you thinking 30? Because if you are, that's great. 34 is 30 plus 4. Do you agree? Perfect. If that's true, then 65, let's break that apart by place value. I should get 60 plus 5. Do you agree? Perfect. Okay, so look at this sentence right here. It says the commutative property tells us that we can add numbers in what? That's right, in any order. Let's write that right here. In any order. So I don't have to answer 30 plus 4 plus 60 plus 5 in that order to get my answer. That would be really hard. But what I can do is I can change the order. So let's grab our tens and put them together. So in this one, I'm going to grab my 30. And in this number, I'm going to grab my 60. Now my tens are together. When we did this last time, we drew place value blocks. These would have been our rods. We would have had 3 rods to represent 30 and 6 rods to represent 60. So this time we've just written the place value. Now let's grab our ones. So I've got plus 4, plus 5. So now I've changed the order. But remember, I'm not changing the sum. All right, the associative property tells us that we can do what in any way we want. That's right, we can group these numbers in any way that we want. Okay, well, let's think about that. Which numbers are going to be the easiest to add together? Would it be easier to add 30 plus 4 and then 60 plus 5 and then add those together? No, that's just right at that original problem. That's just too hard. So what I can do then is I can think back to when we drew those place value blocks. We grouped them together based on their place value. So let's group these tens together. And then let's group these ones together. Now let's solve that. What's 30 plus 60? Yeah, 90. Okay. All right. What's 4 plus 5? 9. Perfect. So if I add 90 plus 9, what answer do I get? Beautiful. 99. Okay. So let's think back. The first thing we did is we broke apart those numbers based on place value. The difference from what we did last time and today is this time we wrote the numbers and the values rather than drawing the place value blocks. Then we used the commutative property to rearrange our numbers and put the like ones together. And then we used our associative property to group the numbers that were the same and add that way to make smaller problems to make this easier to do. Let's try another one. Okay, these numbers are a little bit bigger. Do you think we could do this? Yeah, I think so too. Okay, look at the number 163. I've got to break it apart by value. So in my hundreds place, I have a 1. So that means there's 100. There's a 6 in my tens place, which means 60, and a 3 in my ones place, which is just 3. So I've just broken that number apart by place value. Let's do this one, 325. Well, it looks to me like I've got 300 plus, what are you thinking? 20, good, plus 5. That's that expanded form again that we were talking about last time. Okay, so we've broken them apart. The next step is to use commutative property. Remember, we can switch the order any way we want. So let's put all those ones that are similar together. Let's start with our hundreds. So let's bring our 100 and our 300 and let's put them together. What do you think we should bring next? I agree. I think the 10 should come next. Okay, so here we go. I've got 60 plus 20, And then that only leaves our 1, so let's bring our 1's down. 3 plus 5. So our commutative property just said switch the order to make it easier. Now we're going to use the associative property to group our numbers to make it even easier to add. So what's the best way to group our numbers? Great, yeah, we're going to add all those hundreds together first, and then we're going to do our tens, and then we're going to do our ones. And it's okay to have 3 groups. We've got a pretty large number here. So let's break that down. I've got 100 plus 300. Are you thinking 400? Because I am. All right. I've got 60 plus 20. Are you thinking 80? Good job. All right. And last but certainly not least, 3 plus 5 is 8. Perfect. Okay, now all we have to do is add those together to get our final answer. So 400 plus 80 plus 8, squish them all back together and you get 488. Great job. Does this remind you a little bit of what we did last time? Yeah, it's exactly the same thing. We're just not using our place value blocks. Okay, let's try this one. Think back. What was the first step? What did we need to do with the number 431 and 136 before we could add them together? Yeah, we had to break them apart. Okay. So let's see. I think in this number I see a 4 in the hundreds place. So I'm going to represent that with the number 400. I see a 3 in the tens place. So I'm going to use the number 30. And I see a 1 in the ones place. So 431. Try this next one, 136. Let's see how you do on that one. I'm going to give you just a few seconds. Okay, let's see. Did you do 100 plus 30 plus 6? Great job. Okay, now I'm going to use that commutative property and I'm going to rearrange all those numbers and put all the like ones together. What are you thinking? Yeah, I think we need to put the hundreds together first. So 400 plus 100. What's next? That's right, our tens. Ooh, 30 plus 30. And remember, I have to put both of those 30s, even though they're the same number. If I leave one out, I'm going to be short somewhere. So make sure you bring all those numbers down. And then 1 plus 6. So the commutative property says you can rearrange them any way you want. Now, what does that associative property tell me I can do? Do you remember? Yeah, it says I can group them however I want. So what's the best way to group them? Let's start with our hundreds. And then our tens. And then, of course, our ones. Okay, here we go. 400 plus 100. Beautiful. 500. 30 plus 30. Yep, 60. And 1 plus 6. Perfect, 7. Okay, let's squish it all back together. 500 plus 60 plus 7 gives us 567. How'd you do? Great, okay. Now you try. This time I'm going to give you just a couple of minutes. Think carefully. You're going to break apart the numbers into hundreds, tens, and ones. You're going to use the commutative property to rearrange the numbers and put the like numbers together. And then you're going to group your like numbers using the associative property and then add and get your final answer. Take just a moment. Let's see how you can do on your own. Okay, let's see how you did. I'm looking at the number 421, and I'm hoping that you broke it apart into 400 plus 20 plus 1. Then I'm going to look at the number 258, and I'm hoping you broke it apart by doing 200 plus 50 plus 8. Did you get that far? Fantastic. Even if that's the only thing you were able to do on your own, that's still really great work because you're able to name the place values and the value of each of the numbers in that number, in that giant number. Okay, using the commutative property, I'm hoping you took those hundreds and put them together. 400 plus 200. I'm hoping that you then grabbed the 20 and the 50. And finally, I'm hoping that you grabbed the 1 and the 8, and that your problem looks similar to this. The last step was then to use that associative property to group those numbers. So I'm hoping you grouped these two, and then these two, and these two. Did you get it? Fantastic. I knew that you would. Okay, here we go. Let's do the final piece of it. Let's add. 400 plus 200 should have gotten you 600. 20 plus 50 should have gotten you 70, and 1 plus 8 will get you 9. So when you take all of those numbers and you add them together, you should have 679. How'd you do? Great job. Give yourself a giant pat on the back. You are amazing. Okay, so the biggest challenge of our whole lesson today is to be able to use those big words, commutative and associative, and explain how you're doing your math to your family. So another fun way to grab numbers or to make up numbers is to use a deck of cards. I love card decks. The only thing you might want to do is make sure you take out any of these face cards. They don't have any number value to them, so we're going to just leave them out. If you want to, you can find an ace, and that can be your 1. So what I'm going to do is I'm just going to grab any 3 cards. Let's see, I like this one and this one and this one right on top. So I have, two 9s and a 4. So I made the number 499, right? Then I can grab 3 more cards. Let's see, what did I make here? Whoop, I better take the 10 out too. Don't forget to take the 10 out. How about 859? Ooh, that's going to get me a big number. So now my job is to take these 2 numbers, break them apart just like we did before, and create those big math problems where you can then rearrange the numbers using the commutative property and group the numbers using the associative property and find the sum. But my biggest question here, the biggest thing I want you to really focus on is being able to explain how you're doing the math. I want you to use those words, commutative and associative, because I want you to remember those. Those are really important math words, commutative and associative. Okay? All right. Thank you so much for joining me today. Today's code word is going to be school, because that's what we're doing. Have a wonderful, wonderful day, and I'll see you soon. Bye.